Yeah, welcome to class today. We have a problem that we are to solve from equilibrium, all right? That is equilibrium of forces. We have a meter rule of 100 centimeters and the forces 30 Newton, Q, W, 40 Newton and 27 Newtons respectively are expected to interact on this beam, and we are to determine the value for Q and W. Okay, so our interaction is going to be based on the positions of the forces and then the effect of moment across the beam. So the first thing we are going to do is we consider the forces. So the sum of upward forces equals the sum of downward forces. So what we have, all right, what we have here, the first thing we're going to do is the sum of the forces going up equals the sum of the forces coming down. How many forces are going up? 1, 2. So we now write, if we add Q to 40 Newton, the result is supposed to be the same thing as when we add 30 Newton to the weight and to 27 Newton. So if we do this, we form an equation from there, collect W and Q on one side, and then the numbers, the other forces, the sum of the other forces at the other side. So we're going to have 30 plus 27, that's 57, take away 40. 40 is plus here. It crosses the sign of equality to the other side, becomes minus. So what we have is our Q minus W is equal to 17. Let's call this one equation 1. All right, so the next thing we're going to do is to consider moment. All right, we take moment of the different forces at a particular point. Okay, this point is 50 centimeters because it's a uniform beam. All right, now you can pivot the beam. You can pivot the beam at any point that you want, whichever point you choose. Depending on how you manage it, the result is going to be the same. So if I choose this point, okay, from the question too, they said this one is at 15 centimeters. I should have put that earlier on, but that's okay. All right, so this is at 15 centimeters. So we can put our pivot maybe somewhere here at 0.60. 60 centimeters on the beam. So we now say taking moment of the forces at 0.60 centimeters. All right, so at this point we want to take the moment of the different forces. So when we do that, the sum of clockwise moment will have to be the same thing as the sum of anti-clockwise moment. All right, it looks great at this point. Okay, so how do we take moment? I want you to listen to this, it's very important. We want to take moment of all of these forces at about this point. So this is our into the page. All right, so if we want to take moment, all right, you move from the point of pivot. Then when you get to the line of action of the force, you follow the force. If you come to the end of the force, what you do is you bend towards where you came from. The moment you bend, you begin to turn. All right, and you look at the way my finger is turning. This is not turning in the direction of the clock, wall clock. This is not turning in the direction of the clock. This is turning against the direction of the clock, the second hand of the clock. So I bend towards where I was coming from. Immediately, I begin to turn. Look at the way the arrow there is looking. So this is going against the clock. So we call it anti-clockwise moment. All right. Then we move from the same point to this place. This time, we bend towards where we came from, and then we begin to turn. This is going to be in the direction of the clock. So we call this one clockwise moment. Again, we follow this force, we bend towards where we are coming from. This again is anti-clockwise. All right, that's anti-clockwise moment. Then we follow this from here. Now we follow this one. Go with the force, bend towards where you are coming from. You can see this one is still anti-clockwise. So ACM. Finally, we move from here. We follow this force, bend towards where we are coming from. Then we start turning. This again is clockwise moment. How did you feel? All right. I want you to just take your time and go through all that we are doing here gradually. I'm sure you're going to have very perfect understanding of what we are discussing here. All right. So how do we have taken moment of these forces, but the moment we have to, how do we define a moment? All right. Moment of a force is defined as the product of the force and the perpendicular distance. All right. This sign means perpendicular. So this is perpendicular to this line. 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 And that is perpendicular to this line. So we can possibly take the moment of all the forces, but we take note of those that are anti-clockwise and then those that are clockwise. So we can sum them up together. All right. So we come here for the clockwise moment. This is clockwise. This is clockwise. So there are two clockwises. So the distance, the first clockwise is here, which is Q. The distance from 60 to 15 will be 60 minus 15. That's going to be 45. 45 times Q. So we're going to have that one as 45Q plus, okay, from 60 to 100, all right? 100 minus 60, that's 40. 40 times 27, all right? So if we have it as 40 times 27, or better still, the first 27 times 40. So we have finished with the clockwise moment. The sum means we should add them up together. So the next thing that we're going to do here is to change to anti-clockwise. So this is anti-clockwise from pivot down to this point. This point is 0 point. It will be 60 minus 0. The distance is 60 centimeters. So times 30 Newton. So what we have there means that we have 30 Newton times 60 plus another anti-clockwise moment is this W. So from 70 to 50 is 20. 20 times W. So you're going to have 20 W plus. This again is anti-clockwise. So from 60 to 70, there is 10. 70 minus 60 is 10. 10 times 40. So that's simply going to give us 40 times 10. Now, I hope you understand what we are doing here. Please share this video and make sure you subscribe to our channel. All right. Do as much as possible to drop your comment. Let's have a feel of you, and then we'll be able to improve in our discussions. So the next thing we're going to do here is you multiply this by this, multiply this by this, multiply this by this. So if we do that, we have 45Q plus, if I multiply this, so I have 8, and then, so that's going to be 108 equals, multiply this, we have 1,800, then we have 20W, and then we have 400. At this point, I'm sure you can complete this job, but we're still going to go forward, all right, to finish it together. So we draw our line here. Okay, so we collect the terms with unknown variables to one side. So we're going to have 45Q minus 20W. All right, if you take this one to the other side, we will have 2,000. We add 400 to 1,800, it will be 2,200. You take this one to the other side, it becomes minus. So we have it as 1080. Okay? So the next thing we're going to do is subtract this. So you will have 45Q minus 20W. So if we subtract this one, what we are going to have is we have 0, 2, then 1, 1. That's 1,120. So if we do this, we call this one equation 2. So we are meant to solve equation 2 and equation 1 simultaneously. So that's simultaneous equation, right? From mathematics knowledge, we should be able to do that without stress. So what we are going to do is from equation 1, from 1, our Q is equal to 17 plus W, all right? So we put this value here into 2. Put into equation 2. So we have 45 into 17 plus W minus 20W equals 1120. So if we open the bracket, all right, if we open the bracket, what we are going to have, we have 765. This is going to be 765 plus 45W minus 20W equals 1120. So what we have here, if you subtract this, you're going to have 25W equals 1120, all right, minus 765. So 765. So it means we have 25W. The result is equal to 355. Divide both sides by 25. 142 Newton. So we got our W now. Let's get our Q in turn. We now say, therefore, our Q, which is equal to 17 plus W, our Q, therefore, is 17 plus 142, and the result is 1. We have 5, then 9 Newton, respectively. So we got the result of, got our W there, and then we got our Q there. I hope you learned something. Of course, you can see that it's very interesting. Look forward to our next video on physics, further maths, and mathematics.